Greetings, my name is Deepak Roy, and today I will be presenting my Capstone project for the Data 695 Capstone course, which I took over this summer. My project is focused on global unemployment with disabilities worldwide. In this presentation, I will cover the background description, which includes the assumptions versus actual data. Then comes the exploratory data analysis, which involves the whole process of data exploration. Following the discoveries which were made during my project, finally I will present the models which I used as well as their performance and results, along with the recommendations at the end. The focus here is on unemployment with disabilities for people worldwide. To break down the problem description, we must first decide what will be the focal point of our analysis. Then we need to direct our attention to those countries with the highest unemployment rate pertaining to individuals with disabilities. Finally, we must learn the major factors that influence general unemployment. Media projection and some research often produce misconceptions that contradict the actual data. It is assumed that there is a connection between the media news and the data in the case of unemployment with disabilities. This contradiction creates misinformation as the general public believes there is a direct correlation between the actual data and the media projected analysis. And so the match between them is more fictitious than real. There are often a lot of differences between the algorithmic analysis and the media news projection. For example, during my analysis, I found a lot of discrepancies in the projection of media data about unemployment with disabilities with the final algorithmic analysis of machine learning. So in other words, what I did was a lot of my machine learning, my algorithm, when I was training all the data and performing the data collection, I found there were a lot of discrepancies from what the media has actually stated that if and perhaps a lot of the data was also missing, which I will be talking about later on. This slide here, he outlines the issues of data quality as well as reliability of the data collected. While creating my exploratory data analysis and my data model, I discovered that several pieces of data were missing from some countries. For example, the data shown here of Singapore, the issue was more prevalent for several other countries around the world that had a low GDP. So as you can see here, that for Singapore, for 10 years, no unemployment data was collected in respect to the population. This is what. Now we come to the process and preparation of exploratory data analysis. There are 5 steps to this process. First, we clean up the data by reducing any unwanted columns using the method of feature engineering. What is feature engineering? So feature engineering is a process of transforming raw data into relevant features. Second, we use logarithmic transformation to transform the data. This would be creating our bell curves and all log plots. Third, we would use the bivariate data analysis as well as the multivariable analysis. So a little explanation of what they are, bivariate data analysis is statistical methods for analyzing 2 variables, whereas multivariable data analysis is statistical method for analyzing multiple variables. Fourth, we try to impute all the missing values leading to the last step. Finally, we create the graphs for our models, which involves the ordinary least squares regression and the required plots for the entire EDA. Here is a graph of the entire sampled population worldwide in millions. According to the graph, Europe had the most sampled population worldwide. Approximately 290 million people were sampled worldwide as depicted on this bar graph. Hence, this projects that the European countries have one of the highest rates of unemployment with disabilities. So what this is in a nutshell is that Europe, these would be all the countries in Europe, this would be all the countries in Asia, countries in Africa, North American continent, which were actually sampled in this whole entire data set. Using the data set of unemployment of individuals with disabilities during the period after the recession, I created a line graph using 3 countries, the USA, Germany, and Portugal. As observed in the graph, Portugal was amongst the shakiest countries in terms of the unemployment rate. One of the reasons is that the country has a low GDP. This is evident as countries like United States and Germany maintained a somewhat steady unemployment rate. So the reason, and to explain further that since Germany and US are countries with relatively higher GDPs, their unemployment would remain steady for most of the for years together, as you can see. As you can see in Portugal, since the GDP is lower, that's why it's so shaky that one time it spikes and spiked in 2010, dropped drastically in 2011, spiked up again. So countries with low GDP have this. There's one factor here. Since we are focusing on the unemployment of individuals with disabilities, it's still important to understand the comparison of both unemployment without disabilities versus the unemployment with disabilities. Now to set up a comparison of the rates of unemployment with the 2 data sets, we use logarithmic plots. As you can see, it is observed in figure 1 on your top left that it is left skewed. The left skewed log plot would convey a higher mode, which would mean a higher rate of unemployment for individuals and with disabilities. And like as you can see, since the mode is the highest, that's why that would be why, and like the most frequent values. On the other hand, unemployment without disabilities, as shown in figure 2 on the bottom right, it's symmetrically skewed. This conveys that the mean, median, and mode are all equal, and therefore unemployment for individuals without disabilities is relatively low. And where you can see this is symmetrically skewed, if you draw a line here at the bell curve, then you could see kind of a reflection. So mode, median, and mean are all very much equal. So this would mean numbers equal out in figure 2, the unemployment without disabilities. These are the 7 algorithms that I used to develop my model. The first one I used was principal component analysis to view the dataset from reduced dimensions, which in this case involved dropping rows and columns as seen fit. Next, I utilized the random forest regressor to aid in my feature engineering process. Then I made use of k-means clustering to observe each group of unemployment in cluster form. In my fourth model, I utilized random forest to combine the outputs from the random forest regressor for the next step of analysis. Following the previous model, I used the gradient booster regressor to have a better view of the classifications. In this model, it involved adding weak and strong spots together. In the sixth model, I employed the generalized linear model to analyze any outliers that would enable me to make necessary future predictions. So the final model, which is number 7, lasso and ridge regression, was put to use to aid in my grid search method. Let's talk about model comparisons. These are some of the models used in my process of data analysis. As we can see above, the main variables used in most of the models include year, unemployment without disabilities, which is noted as WOD, unemployment with disabilities, which is noted as WD, and population. Other than these, some other variables were analyzed, like cluster, number of clusters, distance, gender, body mass index, and temperature. The principal component analysis model was very accurate. Accuracy of the data was 88.6%, perhaps, which was proved to be the one that the model is well performing. Next, the random forest regressor had a slightly improved model performance than the other models used. As we see, the regression coefficient was greater than 1. This displays that there is a strong relationship between the input and outcome variables. The variance score of 0.52 shows that there is no significant correlation between the response and input variable. Although the model is very accurate, based on the regression score, the model performance was not the best. The k-means algorithm performed the poorest amongst these three. As we can see, the recall and F1 scores are 0.04, which denotes poor performance. This algorithm has used several other variables in its analysis. Here are the 3 more algorithms that I used during my analysis. Amongst the best performing algorithm was the random forest algorithm, which used unemployment with disability as the only variable. As we can see, it had a very high accuracy score. The gradient booster regressor scored quite poorly. As you can see, it had a large difference in data points as depicted by the mean squared error. The generalized linear model was amongst the best performing linear models, as the accuracy score was 95%, and its predictions were quite accurate. The last 2 algorithms that I used were Grid Search CV, which utilized both lasso and ridge regression. As shown here, more variables were taken into consideration for this analysis, such as health, temperature, and age. All these other variables aided in the model creating another dimension of factors, such as climatic condition and the age of the population, which directly affected the analysis of the outcome. The model performance here was average because more time was required for computing several complex variables, as you can see, which I had discussed that for like the age, gender, BMI, and temperature. These were also the and to explain a little further, these were also the some more additional factors for this ridge and lasso regression that were influencing this unemployment as well, like the health and this is where health comes in with stability essentially. Let us assess the performance of the models used. Now, based on the accuracy scores above 80%, as we can see, my top 3 best performing models were the generalized linear model, random forest algorithm, and principal component analysis. As you can see, they all had their performance model score that was above 80%. The average performing models were random forest regressor, lasso and ridge regression, with an accuracy score of 40 to 60%, as seen. The models with the lowest performance with a score below 10% were k-means clustering, as well as gradient booster regressor. To my understanding, the generalized linear model performed the best because the analysis consisted of a regression problem, and this model has the best algorithm for it. During this project, I realized that there are a few important things that need to be kept in mind while performing data analysis. My first recommendation would be to make sure that there are no missing data. The data collected need to be scrutinized for accuracies both in number and procedure. Both number and the procedure and source of collection. This would eliminate any form of errors and misleading information to be fed into the models for analysis. The source, mode, volume, current, and validity all need to be validated for a more accurate analysis and future prediction. Clean and complete data results in more accurate and dependable analysis. So, thank you everyone for watching. It's been a pleasure. And I wish everyone all the best.